Lab 20, example 7. We have the function f of x is equal to 2x squared plus x plus 1. We want to find the vertex, the x-intercepts, the y-intercept, and the range. So jumping straight into it, we want to find the vertex first. The vertex is going to be a point, so it's going to have an x and y value. Our x value is going to come from the formula negative b over 2a. And our y value is going to come from the formula of just plugging this x value into our function. So it's going to be f of negative b over 2a. Now this a and b are referencing the formula of a typical polynomial, which is ax squared plus bx plus c. So if you notice, our a is 2, our b is 1, and our c is 1. So plugging into our x formula, negative b is going to give us negative 1, divided by 2 times our a, which is 2. This is going to give us negative 1/4. So now that we have our x value, we're going to find our y by plugging this negative 1/4 into this function up here, everywhere we have an x. So our y is going to be 2 times negative 1/4 squared plus negative 1/4 plus 1. So negative 1/4 squared is going to give us positive 1 over 16. And then negative 1/4 is just negative 1/4 plus 1. 2 times 1 over 16 is 2 over 16, which can be simplified to 1 over 8. So we have 1 over 8 minus 1/4 plus 1. We need to get the same denominator. We can get the same denominator of 8 by multiplying this fraction by 2 over 2. And 1 we can rewrite as 8 over 8. So I'm going to do that. So we have 1 over 8 minus 2 over 8. 2 over 8 is the same thing as 1/4, plus 8 over 8, which is 1. Now that we have the same denominator, we can add the numerators. So 1 minus 2 is negative 1. Negative 1 plus 8 is 7. So we have 7, 8. So our vertex is the point negative 1/4, 7, 8. So now that we've figured out our vertex, we need to find out our x-intercepts. So rewriting our function up here, we have f of x equals 2x squared plus x plus 1. Our x-intercepts happen when y is equal to 0. So we're going to substitute 0 in for f of x. This gives us 0 is equal to 2x squared plus x plus 1. And you can attempt to factor this, but it won't factor nicely. So I'm going to put it into the quadratic formula. The quadratic formula is x is equal to negative b plus minus the square root of b squared minus 4ac divided by 2a. Plugging in, our b is 1, so negative b is going to give us negative 1 plus minus the square root. B again is 1, so 1 squared is just 1. But I'll write it like that anyways. Minus 4 times a is 2, times c, which is 1, divided by 2 times a, which is 2. So we have negative 1 plus minus 1 squared is just 1. Minus 4 times 2 times 1, this is minus 8. Divided by 2 times 2, which is 4. This is equal to negative 1 plus minus the square root of negative 7 divided by 4. And this is when we begin to notice that our x-intercepts are not going to be in real numbers, because the square root of negative 7 is imaginary. It is it is not in real numbers. It is not a real number. Anything negative within a square root is going to be an imaginary number, because the square root of negative 1 is equal to I. So we can rewrite the square root of -7 in terms of I. This would be the square root of -1 times 7, which is the square root of -1 times the square root of 7. And so this is equal to the square root of 7 times I. So anything with I in it is going to give an imaginary number, which means, so this is not an element of the real numbers, another way of saying it's not a real number, which means that our x-intercepts are not real. So we have no real x-intercepts, which means our graph never actually touches the x-axis. That's what that means. So moving on, we want to find the y-intercept as well as the range. I'm going to rewrite the function one more time, 2x squared plus x plus 1. So our x-intercept happens when x is equal to 0. So we're going to plug in 0 for all of our x's here. So we have f of x is equal to 2 times 0 squared plus 0 plus 1. This term and this term will go to 0. So we're just left with f of x, which is also y. Y is equal to 1. So our y-intercept is the point 0, 1. Lastly, we want to find the range. The range is the possible y values of our graph. So we're going to need the vertex. The vertex was the point -1/4, 7, 8. I'm running out of marker. That's showing up, I hope. Okay, so, and if you graph this, you'll notice that it's going to be a parabola. Parabolas have two forms. If they're positive, they open upwards. If they are negative, they open downwards. Because there is no negative in front of this first term, we know that it's positive, so it opens upwards, which means we can sketch a little bit of a graph. We have our vertex at -1/4, somewhere at 7/8. So it's up here, and it opens upwards. It opens upwards. Okay. And you'll notice first that this is the reason also why we had no x-intercepts. It never actually touches the x-axis. So, if we're going to look at our range, we're going to go from the bottom of our y-axis to the top of our y-axis. If we start down here around y equals -infinity, even if we go outwards anywhere, we can't find the graph anywhere. And that's the same here, that's the same here, that's the same until we get to 7/8. At 7/8 we are able to touch the graph, and we'll be able to touch the graph at any point in the y-axis onwards. So our range, going from bottom to top, starts at 7/8, including 7/8, and it goes until infinity.